off worksheet 5. Any questions you might have come across up, and again, this is not being marked off today, so I just want to see if there's any that we can answer and help out. Yeah.
So one of them that I tried and looked at all of them, but one of them was number 4. I got yes, no, no, yes, but C for number 4 is actually yes.
Okay.
And I don't understand why.
Let's take a look. All right. So we have this followed by some sort of plane. Let's see if we can. I know it's not perfect. So you have D up here. That's a D. And then you have another line here. That's calling this C. Point C. Then you have point A, point F, point B. Put an arrow at each end, so these are lines, not segments. And then you have a point E down here. So that, for the most part, looks like everything. So you give another name for line AB, well, it could be line BA, it could be line AF, it could be FA, FB, things like that. Oh, wait. So you're at number 4. Decide whether each set of points are collinear. So A and B, definitely, they're on the same line. D, A, and B are not, because though they're on lines, D and A are on the same line, and then A and B are on the same line, but D and A and B are not. D and C only. Okay, this is where you said no and it said yes, correct? This is why it works. You gotta think a little bit outside the box, but you have to realize that, is it D and what? D and C? There's the line that they're on. So you had to realize you could add to it. And then A, B, and F, yes, they are all on the same. Is that okay?
Mm-hmm.
So sometimes you might have to add. They might not have everything there, so you realize that 2 points are defined by a line. Any other questions you might have come across on the homework? Yes.
So another
Number 1.
another name for AB could be
Another line for AB, so
it's like BA and FA, but and then number 3, why couldn't it be like BA and BF?
okay. We are going to actually answer that further today because it talks about it's a line segment. Because if you look, it just has the, and I'll finish that notes today. So that question will be answered today. Is that all right? Yeah.
When will this be due?
Monday. Yeah. You don't ever have to ask. Just go ahead and take care of it. Yeah, buddy. Any other questions you came across? And I think I will be able to answer all the rest of the questions today off this worksheet. Yeah.
Okay, so I'm pretty sure that I know, but what is coplanar?
Coplanar, they're on the same plane.
Okay.
So collinear means, collinear is all on the same line. Coplanar would be like this. So, but collinear points are coplanar, but you can't have collinear points to define a plane. Yeah.
So, adding on to hers, so, C, B, and A. A and B are on a line, but C is not, but they are all in the same plane.
Right, so they're coplanar.
Okay.
So when it asks like give another name for FB, line segment FB, does it mean like what it would be considered like collinear or coplanar? Or
Oh no, so if they're looking for another name, so this line right here, I could name this AB, BA. I could name it AF. I I can name it FA, and then even FB and BF. And on lines, that's fine to do because the lines will go forever opposite directions, so it's going to always incorporate all the points. We're going to get to a little bit later in today's where it would be not all the time it's going to work that way. But as far as the line goes, it's kind of like the general saying, you had 60 different points on this line that goes forever. All you need is 2 of those points, 2 different points to name it, and it doesn't matter which 2 you would name. Okay. Yeah.
So, for number 5, I just didn't. So B, A, and E are not in the same plane, but it says that they are coplanar.
For each, decide which. So CBA, so C, B, and A are.
Yeah.
Okay, and B, A, E, B, A, E. Those also are, because think of a plane goes 360 degrees in any direction. So B and those are not collinear points, and it's 3 separate points. There is a plane that those would identify. So think of me taking this board, and I can change it this way, this way, this way. I can somehow make a flat surface that would work, that would incorporate those 3 points to be on it, especially in the 3D. So they're trying to represent the 3D on there.
Then why wouldn't it be yes for D2?
B, let's take a look. C, A, B. So those 3 are definitely on the same plane.
Yeah.
And then D, because it's this. Here's the plane that those 3 points are on, and here's D. This plane cannot include this point up here. So it has 3 of them that are sitting on this plane. So watch.
There's
Watch. Here's your 3 points. Those 3 are definitely on your desk plane. Okay? Is there any way you can make your desk stand flat like that, incorporate that point? That's why. That's what it's doing.
But then how can you have E with the B, A, and D?
Letter C.
Yeah.
B, A, D. So B, A, D, and E. Okay. Take this wall right here. See this line right here? If I incorporate a point in that corner and a point right there, they're on that line, which are part of that plane. And then if I take a point there and a point there, so we're just talking about that wall. So the hard thing about it is if you were to think about this floor, so put both feet on the floor flat. So you have 2 points. Here's my foot here, and here's my foot right here. Are our feet still on the floor? That's what's happening. Even though like our feet are lined up here, and this one isn't, it's still on this plane, if it were to exist. We good? We'll fill you in. It'll be good. We'll get you. Can I go off, or can we go off? I'm not gonna go off on anybody. Like entertainment, yes. Let's go back to those notes from last time. Segments. Whoop.
Oh, thank you.
So coplanar points, and sorry, but today I don't have quite as of a neat thing talking about multi-dimensions. Though it was pretty cool. Let's see, but so coplanar points. Coplanar points are, if you had this, those are coplanar. So I'm going to say yes to that. These are also coplanar but I can't use those to define a plane. Let's say that one more time. So the three red dots are coplanar. The three blue dots are also coplanar, but the three red dots I can't use to define a plane. The three red dots can be used to define a plane. The three blue dots can't. Why? Hang on, did I say that right? So these can define a plane. These can't define a plane. Yeah.
They're on the same line.
On the same line, exactly. Okay, so collinear points can indeed be coplanar, but I can't use the collinear points in a series of three to define a plane itself. And the plane we can talk about here is the smartboard that I'm using. So these 3 points cannot define this smartboard plane, but these 3 points can because they are not collinear. So coplanar points, yes, obviously 2 of them will always be collinear. So I could create a line here, and I could create a line here, and I could create a line here. So being I can create 3 separate lines, that's great. And each one of those, or 2 of those points each time is used on 2 different lines. So I can use that to define, but I cannot draw multiple lines through these 3 points because they're already collinear. Okay? Now, a line segment is going to change things a little bit. So remember, if I name a line, I'm using 2 letters. Okay? And I'm putting a line above it, and there's an arrow going both ways. Agree? When I talk about a line segment, so let's say we have a line here. We'll call this X, and we'll call this Y. So I can call this as line XY. Yay? But if I wanted to make it a line segment, it's a line segment which just includes the endpoints and the middle part. So a line segment is a smaller, it's a section of a line. It's a portion of a line. Okay? And they're named 2 different ways. So if you see just a bar above an XY, that means you're talking about a line segment. If you see arrows pointing both directions above 2 letters, you're talking about a line. A line goes on forever in both directions, in opposite directions. A line segment starts and ends. There's a region of it that we're talking about. And then we can call these the end points. And so things that you need to know is segment XY is equal to segment YX. Okay, they're equivalent statements. You're talking about the exact same set of points. If I were to start here and go this way and get here, I'm going to include the same points if I started here and went this way and ended here. Okay, so they can do it 2 different ways. Now, let's go with, let's just put an arbitrary letter in there. Let's call it M. Okay? Line segment XY is not the same as line segment XM because X to M would also include this region here. So I can't, if I have 3 points defined on a line segment, the 2 furthest out ones are the ones that identify what that actual line segment is, not the inner one. So if I wanted to incorporate this whole region as our line segment, the only way I can name it is XM or MX. And again, I'm not involving Y any longer because now I wanted to go from the X to the M, and we just have to have another point that was defined inside there. Okay? Can I move on? Yeah.
So, let's say that there's like XM, but
Okay.
you just want to identify XY. You just do XY or
Absolutely. So if I wanted you to identify all of the line segments in there, and let's say we're not, just for sake of time, we're not going to worry about the flip-flop of the letters. We have XY as a line segment. We have YM as a line segment. We also have and then the flip-flops of the letters. Okay? But XM incorporates more points than XY as far as the segment goes. But if I were to name that as a line XY, like line XM, line YM, line, any combination of the two letters, if you talk about a line work, because the line goes forever and ever each direction. The line segment, because you have a start and stop point. It doesn't. I got a kink in my neck. I don't know why. Okay, segments are named by using the two endpoints. Okay? So again, this is segment AB or BA. This means the exact same thing. If I had another point identified in there, it's just a bonus. But if you wanted this segment here, you include those as the endpoints. If you wanted the whole segment, you don't use this letter if that is some arbitrary value. So I'm not even going to put a symbol in there. Okay. Now let's talk about array. Arrays are named by using the, bless you, using the, there's something here, what's here? Whoa, sweet. What did I just do? Something happened. Oh, okay. Arrays are named by listing the end point first, and then naming any other point on the array in the direction that it is headed. Okay, so line AB, yes? Agreed? If I named this is not equal to, that's not the same thing. As far as lines go, yes. As far as line segments go, yes. As far as array goes, no. Because this means going from here that way, and this means going from here and going that way. Okay, so when you name array, you have an arrow on top, okay? You have an arrow on top of your letters. The first letter indicates your starting point. The second letter indicates the direction you're going. So if I had another point labeled right here, let's call this J, segment array AJ, and segment AB, oh shoot, I just said the wrong thing. Ray AJ and ray AB are the same ray Y. Yeah.
So going in the same direction.
Same direction and? Same line and? Same start. So if I were to say ray AJ and ray AB, being that AJ and B are all collinear, meaning they're laying on the same line, I can, being that both start at A, J will obviously incorporate going through B, and B will also, if I continue in that direction, incorporate J. So arrays are named by listing the endpoint first, then naming any other point in the array in the direction that the array is headed. So starting points go there. So give me what the name of the array that you're going to talk about there. Go ahead.
SP.
SP, I agree. Array, SP. What else works? Yeah. ST. Does any other array work for that whole thing? Yeah. TP. TP, I agree with you, is array, but TP is going to start here and go there. And if you want to name the whole thing, you have to incorporate that section. So that that, though I 100% agree that TP is array, it does not define the entire array that we're talking about on this problem. Okay? If there's anything in there. All right. Opposite rays. These are rays that are going different directions. So if I talk about ray FG, and I were to talk about ray FE, what can you definitely tell me about those two rays? That's obvious right off the bat. They are opposite. What else do you know about them? What do you got? They have the same starting point. So FG and FE have the exact same starting point. FG appears that it's going to the right. FE appears that it's going to the left. Notice I still create the arrow always going to the right when I write it. I don't write this as it's going this way. Okay? Yeah.
Why don't you write it that way?
Wasn't at that meeting that they decided not to. I think maybe because you might have lines that go this way, and then it's not going to matter. Does that make sense? So FG and FE have the exact same starting points. They are opposite rays of each other. They go in opposite directions. Both rays happen to lie within line EF or EG or FG or any combination of those letters named line. So they're opposite rays. Opposite rays are normally 180 degrees off of each other. And I say normally because I don't want us to define it as always. If you ever get into non-Euclidean, then you're going to call me a liar. Non-Euclidean, 5 axioms don't work. 4 of them do. You know, like what the heck is he talking about? Just go with it. Yeah.
How come the arrow for FE is pointing to the
It will always go to the right.
Oh,
So this will always indicate the start point, and the arrow will always point to the right. And why did they do it that way? I wasn't in the meeting when they voted. So it was like the presidential election like five times ago. I didn't vote. People were like, why didn't you vote? Wasn't old enough. Gosh, how many elections have I voted in? Who was the first president I voted in? Who was Bush, Clinton, maybe? First Bush? That's been a while. Yeah.
So for rays, can it only be 2 or can it be more?
You could name more, but the first letter will always be your starting point.
Okay, but like also can it like is it only FE and FG or like
As far as opposite rays, so we're just trying to determine. I have one ray going this way, and I have another ray going this way. So we're just trying to define opposite rays. But could I, if let's say I'm creating this to be my starting point, could I say E, F, G as a ray? That would mean I'm starting here and going forever this way. I think this is completely appropriate because they're already on the same line. This is my starting point by what I was trying to aim for. So yes, you could use 3 letters. It's not necessary though, but just make sure your very first letter is your starting point.
but there's only like 2 rays per
From this starting point, yes, because on a line there would only be 2 opposite rays in that case. As far as the letters I have defined up there. Okay, yeah.
So the rays only represent or only are on lines, not segments.
I guess I could say if I were to talk about ray EG, where E is my starting point, then line segment EF is part of that. And I guess I could say, a ray has a line segment that could be defined inside of it as well as a line. So a line is your general. Array is start and never ending in some direction. A segment starts and ends. Is that okay? Can I move on? Name 3 collinear points. These are on the same line. I see DBF. Someone sees someone else? Shout it out.
ABC.
ABC. Any other? C. What do you got? C, E, F. Ooh. Oh, really?
I can't tell.
So this is what's hard. Are we looking at like a parallelogram laying flat with a line going through it? I think what this is, because this is dotted, I think this is a plane that's kind of sticking out towards us. Okay, with a line that goes across. So if that was the case, so let's say I were to talk about that, that would mean I have, let's call this plane like this. Then I don't think I could say that C, E, and F are laying on the same line, because C and E are within this plane here, and then this plane, the flat plane, and that really looks weird. I wish we had like 3D glasses we could put on and make the board 3D, and you're like, dude, it's sticking out at me. But I don't. But I think that's how we were looking at it. But we have to make sure that we feel good about what's taking place with that. I don't have anything as a perfect, wonderful example. Tissue plane, still with me? That represents this. Is that okay? Hold the bottom. Okay. Here's the line now. So I would have 2 points, C and E, that happen to be on the tissue, and then I have the point of my pencil being F. So we could do it like this. Okay, so can you see the 2 black points? And now I'm going to talk about the tip of the pencil here. Come on, baby. There we go. So C and E are the 2 black points on the tissue, and the tip of the pencil is F. So is there a single line that would work there? Does that make sense? Can I bring it to you? Yeah. Collinear. So collinear points will be on the same plane at some point, but they don't have to lie on the defined point. So think of this pencil as the plane being the tissue and the pencil. Let's put 3 points on the pencil. One of them could be the middle where the plane intersects. It doesn't go to 2 points. The rest of the tip. Don't have to lie on the tissue. It could if I did this. And they're lying on the same plane. Let's do it. So 3 collinear points. So ABC totally works, DBF totally work, or some combination of those letters in that order. Give 2 other names for line BD. You make those arrows a little bigger there. Line BD. So BD is this line right here, yes? So I have DF, FB, they work. So BF and DF, or the flip-flop of the letters is fine too. Name 4 coplanar points. So here, 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 and here are on the same plane. Now it appears that that line is lying on that plane as well. So those are 4 coplanar points. Give another name for plane T. Plane T, I need to use 3 points that are not collinear. So, oh shoot, I can't see. Is that B, C, and E? So B, C, and E in whatever order I want are another name for plane T. Why can I not necessarily use this letter up here with, why can't I use that value up there with those letters? Like, dude, you just covered it up. I can't see. I know. Yeah, go ahead.
Because they create a line and they don't like define the entire thing.
Right. So what you got to think about is, try and think of something in the room that would make sense. So if you were to think about this point here, one here, and one here, they're definitely on the same line, but could I take this whiteboard and start swinging it around this way to create 360 degrees of planes? The answer is yes. So those 3 points right on the edge of the whiteboard can't be, they might lie on the same plane, yes, but I can't use those 3 to define that plane because they happen to lie on the same line. Yeah.
So for the number 3, name 4 coplanar points. I'm still a bit confused on that.
Okay. You see this plane here. So this, and this all happen to be on that plane. Now, it happens to be that ABC are also collinear, and that line is lying on top of that plane. So think about the floor and this white cord. And let's pretend that white cord is a straight line. I know it's not. So the floor and that cord contains the same points, but where your foot's sitting is in the plane. It's not on that cord, but it's all on the same plane.
So you could put either, so you could put A, B, C, and E, since those are obviously the only 4 that are in there. Okay.
Did I name everything there? Okay. Ooh, where did we go? Is that it? Is that all the notes? There's nothing else? Oh, that's my garbage. Oh, there's more. Where did that come from? It's like, dude, are you kidding? Look at all this. You missed out. Oh my goodness.
Where are the slides?
Oh, I just haven't hidden. Give another name for line PR. Another name for PR. PQ. Okay, or anything else? Another name. Name a pair of opposite rays. I think QP. What's the opposite ray to that? QR. Those are opposite rays. They have the same endpoint. Could I have done QT and QS? Absolutely. Name all the rays with endpoint Q. QT. QP. What else? QR. QS. That's pretty much it as far as that definition. Decide if each statement is always, sometimes, or never true. Any 2 points are collinear. Point here and point here. How many lines can I draw through those 2 points at the end of my fingers? 1. What about these 2 points? These 2 points. Is there any way I can change my fingers to the points of my fingers that I define a different line? So any 2 points are collinear. Always true. 2 points will define a line. Okay, so they're always collinear. Any 2 points are coplanar. I think that's always going to happen. Think about the floor. Put 2 points. They're on the floor. Now, here's the tough one. My finger here. My finger here. Is there a plane I can draw somehow at some angle that's going to incorporate my 2 fingers? What about now? Now? Now. Yes. So any 2 points can be coplanar as well, and that's always. So always, they can't walk. Any 3 points are collinear. Sometimes. So I have that point X on the ceiling right there, and then your 2 shoes that are sitting on the floor. Your 2 shoes are collinear, but that point up there on the ceiling is not. But it sometimes could happen because you can talk about your 2 shoes and your neighbor's foot who's also on the floor. Okay. Any 3 points are coplanar. Your 2 shoes and that X. Is there a plane that you can draw or create that'll incorporate that X in your 2 shoes? So that's always going to be true. Any 3 points are coplanar. And even the ones that happen to lie on the same line that are collinear are also coplanar. It's just you might not be able to use those 3 points if they're on the same line to define your plane.
So sometimes.
I think it's always. 2 lines intersect at a point. Yeah, when don't they? When they're parallel. Can anybody think of a time that the lines aren't parallel and they also don't intersect? Maybe. Okay, that would be infinite. Yeah, but I like that. I like your thinking. Yeah. Yeah,
When they're line segments.
could be. 2 lines, what are we on? 2 lines intersect at a point. That's, what about those 2 lines do we understand? Ready? Okay, you see the black line over there between Monday and Tuesday, it's going left to right. That's the line, yes? Agree? See that line over there on that plane over there on that wall? See it? What about this line here? Will that line right there intersect with that line right there? Maybe, it could. They are on different planes. This is on the front wall plane. This is on the side wall plane. This line right here, and that one, that's going to go above it or below it. So is this line here going to intersect with that line right there? Maybe not. Let's change one, different one. Okay, turn around and see the chocolate sprinkled donuts as I love Tori. Kind of in the middle of the room, lights on it. Let's say I were to draw a line on that poster going left and right. So from that window to the door. Still with me? And let's say I drew the line on that pointing those 2 directions. And then I draw a line like this up here on this board. Will that line that's pointing opposite directions there intersect with that line right there? No, but are they parallel? No, because you know parallel lines have to have the same slope, right? But that line is not parallel to that line because they're on 2 different planes. So 2 lines intersect at a point. That's true if the 2 lines happen to lie on the same plane. Ooh, making up rules. 2 lines intersect at a ray. Oh yeah. Who didn't get their packet of papers?
That's another. I think that's also another class's maybe.
Oh, you know what that probably is. Sorry, I didn't mean to give you my other class. Now you get to see who's in my other class.
They were mixed.
That makes sense. Thanks. 2 lines intersect an array. 2 lines, let's see, 2 lines intersect I have this line drawn and this line drawn. Two lines intersect in a ray. I don't really understand that. I'm just going to say no. Never. I don't like that. I don't like that question. So let's just do this. We'll just break out with going with crayon. I'm just going to crayon it out for now. All right, a line and a plane intersect at a line. A line, and a plane intersect in a line. Can I borrow your crutch?
Yeah.
Cool. Floor and this crutch, are they intersecting right now? What?
No.
What's down here? What am I touching it with? What is this? A point or a line? It's a point. So can I make this crutch touch the ground to make a line? Yes or no? So the line and the crutch have to be on the same plane in order for that definition to work. So I'd say sometimes. You didn't know you were bringing in visual effects. A line. So I think sometimes. Oh wait. That's this one, isn't it? Sometimes. Yeah, that's how I write. A line and a plane intersect at a ray. I don't know. We'll throw a sometimes in there because I can't think. We'll do this kind of sometimes. We'll call that the answer. You remember writing the answer like this? So you felt you could be a lawyer with your 4th grade teacher and say, "Nuh-uh, that's an F. I write all my F's like that." Like, okay, write your name, Fred. Well, my name Fred's like this. Oh, I thought you wrote your F's like this. Oh. All right, a line and a point intersect. A line and a point intersect. A line and a point intersect in a point. I'd say they have to. That point definitely has to be on that line, but yeah, I'd say a line and a point. If that line does happen to intersect that point, it's going to be a point they intersect at. Two planes intersect in a point. No. Line. Ceiling, wall. Still with me on this story? Ceiling and wall intersect. It's a whole line they share. Two planes intersect in a line. Yes. Always. No. When don't they? Ceiling and floor, what are those planes to each other? Parallel. So that's only going to be a sometimes situation because two planes intersect in a plane. You could name the exact same plane over itself. That means you have infinite solutions. And the intersection of three planes is a line. Floor, wall, other wall. They intersect as a point. So this is never. That should be a point. Am I done? What's 10? Two planes intersect in a point. It's got to be a line. 12. Two planes intersect in a plane. Yes, if they're the exact same plane. Yeah, the floor and the carpet.
So sometimes.
I'd say all or sometimes. Algebra review. I think you guys will be all right with this. Homework is, this is what I assigned last night, right?
Test on my birthday.
And then test on the Wednesday. On your birthday. Bring cupcakes. And also coming out to you, this assignment that I'm handing out to you. This assignment that I'm handing out to you. this assignment I'm handing out to you all with me on this story
Yeah.
is going to be due on Wednesday. This assignment that I'm handing out to you will be due on Wednesday. The assignment worksheet 5 is due on Monday. Huh? Sure. Here, I'll just get back. So the free-handed one is coming out to you guys